Okay, let's do it to it. I don't have much time, and I'm trying to get a lot done, so let's go for it. Pop out the chat real quick, just in case anybody wants to stop on by, and let's just dig right into this. So, if I were going to... I did all this hemming and hawing last time, and then drinking sangria and just going off the rails. What we really need to do here is... let's go to the overhead. I've got Gal in this programmer. If I was going to build this keyboard matrix scanner and converter to serial, Nintendo-style serial deal, without, like, if I had the proper chips and I didn't just have the 7400 crap that I do have, which is insufficient, I would use a parallel to serial shift register, some kind of counter, and I guess like a I kept calling it a demuxer. I'm going to keep calling it a demuxer, but something that takes, you know, like a I don't know, 4 to 8 decoder to step through the matrix lines. That's what I would use. I think I could build this whole circuit with that. I don't have those, so let's just plug ahead with literally, I was kind of overthinking it last time, just literally take 3 gals, implement those chips in them, be done with it. That way I have them. Lawless, good to see you again. I know you were here last time, so today I'm going to actually attempt to make more progress. So for the first one, what I was saying last time is true, which is kind of annoying. For any transition in any of the D flip-flops inside of the gal that we have, which includes latching the inputs, we need to use the clock. But that's not so bad, because I can literally just have an extra clock step in there where I assert latch and then clock, and then that'll just be a dead clock, and we'll ignore it. Or if things work out really great, the latch will just... I'll have to write this to the gal and do some quick testing on it, because if we didn't have to have an extra clock and we can just use that first clock and it properly has the first bit that was latched just flow out the data line just right, then everything will be fine and I don't have to worry about it. But if not, sorry, it'll be fine, because it will be, I was going to say a multiple of 8, but we're not going by the multiples of 8, where you have 6 rows. Okay. Not going to blab like I did last time. Let us just implement and I actually have taken the time to save off this PLD file elsewhere, like I said I would do last time, and like I usually don't. But last time we just quickly defined our input pins and our output pin. Realistically, every output pin on a gal, on this kind of gal, is tied. Oh, we'll see how this goes. It is storming outside, FYI. So if my connection drops, that's going to be the way it is. Sorry. Anyway, realistically, we'll have like 7 or 8 outputs, because each phase of the shift register will be one of the flip-flops, and the output pins are directly connected to the outputs of the D flip-flops on a gal like this. So that is what it is. And then our serial out will just be the... I mean, it doesn't matter which side we go from, but it'll be the lowest or the highest bit of those pins. So let's just go ahead and start implementing this. And our basic ideas for each pin, for each flip-flop, if latch is high, then its subsequent value will be the value of the input pin. If it is low, then, if latch is low, then it will be the value of the next flip-flop in the chain, which causes the shifting action. So let us just implement that, which for starters, we're going to need to declare, I can't just have D out like I did before. I'm just going to relabel again. Let's see, so pin 19 is the one across from pin 2, I think. Let us see. Yeah, 19 was this guy. So I guess if this is our input 0, then this will be our output 0, and we'll just increase from there. Actually, this is our input 0. This is 2 is our latch, 3 is our input 0. Whatever. So we'll just go from here. So pin 19 will be, we will call it, let's just call it Q0. And we'll go down from there, and you know, we just need 7 of them. Yeah, we will do 7. So 18 is Q1, 17 is Q2, 16 is Q3, 15 is Q4, 14 is Q5, and that covers all of our, we have rows 0 through 5 in, and then we need another one for our call sense, and I'm just going to go ahead and call that the same thing. 13 is Q6, which is going to be our one for call sense. But and then it will be pretty relatively cut and dried. I believe in Kupel, if you just were like assigning static logic that is just combinatorial and not what's the word, involving registered, I guess, then it would just be an equal sign like this. But I believe in Able, much like a lot of other hardware description languages, I think it's colon equals for on the next clock it becomes. But we will see when I try and build this. So Q0 will be if there are almost certainly better ways to write this, but it will either be latch, if latch is high, and the value of R0, because if latch is high and we get a clock, then on that clock, then the current value that's on the R0 pin should go into the Q0 flip-flop. All of the flip-flops should get loaded. Otherwise, which I believe pound is OR, we do, I'm just going to be, have you noticed that I'm a very paranoid developer? I'm getting add an extra parenthesis, because I just don't know what the order of operations are in Kupel. If latch is low, then it's going to be the value of Q1, which is the next flip-flop in the line. So this is pretty much what all of them are going to look like, and there's probably some nicer way in Kupel to, do this for multiple pins, but I don't know what that is, so I'm just going to copy this a few times. But that should pretty much be it, is if we clock and the latch is set, then it gets the value from the corresponding R pin. If the latch is low, then it should get it from the next register in line, and that's it. And let's see, we have 6 of these bad boys. So just bear with me as I update the numbers on all of these. 1, 2, 3, 4, and fat finger. 5, 6. And this is going to be 2, 3, 4, 5, 6. And I mean, for this one, we can just, there is no Q7, so this will just become 0. And that is that, I think, really. So let's see if that builds, and then I think that's our, basically our clock in a row and shift out a row of keys into the NES chip done. Which there is a standard 74 series logic that implements this, and again, I don't have one sitting around. So let's try device dependent compile, see what it does. Errors encountered, what are they? Device not in library, ATF16 V8B. Also, John Georg Kruger, I am trying way too hard to pronounce my, I mean, that's got to be German of some sort, right? Anyway, good to have you. Hello to you. Right, so let me, I think there's a way to look up the parts library in here. Devices. And ATF. Oh, it says, yeah, they have these weird device mnemonics down here. So for a DIP Atmel ATF16V8B, which is what we have, the device mnemonic is G16V8A, because why not? Right, I forgot about that weird thing. So, yeah. Oh, and you know what I also just realized? I'm specifying R6 here. R6 is not a thing. This would be call sense, which is functionally the same thing as R6, but... Sweet, 7 errors. I missed how many errors there were last time, but... I'm sure that's different, and different is better. So it doesn't like something about... Says there's a missing semicolon, which is odd because I most definitely have semicolons at the end of each of these. Okay. Just making sure I don't have any obvious typos. I'm curious if, because also you can, it may be represented as a dot extension and then D for the data input of the flip-flop. Haven't done this in a while. I have files for other stuff that I have done with these gals sitting on another laptop. But not here, so we will just have to see. Yeah, and then it took me a while. The one thing I do remember is for these gals, like, you can't specify, like, normally if you wanted to say the data input on this flip-flop, that this pin is a registered flip-flop, and it's, and actually, in fact, I don't know if you have to call these registers. I don't think so. I think you just call them pins, even though they're flip-flops. Anyway, so, you know, just like the .d extension potentially means this is the data input of this the flip-flop on this pin. You might have one called .c or .clk, depending on the extensions your particular device supports. And you can connect a clock from any pin, or, you know, any pin as the clock to that input. They call it an extension on that device. But that is not a thing on these. It's just implied if you are using registered pins like this, in whatever way you specify that you're using registered pins, the clock is just automatically always routed to those flip-flops, and it switches to use the flip-flops mode, and that's it. You don't have to specify the clock. It's just that pin is fixed to being a clock input pin. Deal with it. So that's always fun. And I think I had that on right then. So let's run this again and see if it likes the .d syntax better. Yay! I got a warning, but no errors. Missing header items. I'm sure because, like, I deleted the line that was, like, I don't know, product and stuff. But this should have made me a file that I can theoretically write to this gal. So why don't we try that? And then I will plug it into a circuit board here and see if it does what I expected, and if it does, then we are well on our way. So, we are no longer programming an EEPROM, we are switching devices to an ATF 16V, all please, 16V8B, and I think it doesn't really matter which one of those we select. And let us load. Yep, right there. So I had saved the source file in our it's just a PC NES folder, and this JED file is the programmable binary that gets flashed onto there and sets the connections so that the logic is connected the way that you specified. So I should just be able to. I don't know that there's anything special I need to do here. REC4, verify after, sure, whatever. Program, let me make sure that I am not setting the lock bit. I don't love this encrypt chip check box, but I'm not gonna mess with it. We'll find out. If I brick this chip, we'll find out. Yay! Well, this much is working. It'll program it. Cool. Now, let's see if I try programming it again. Yeah, that looks fine. So, I think I set the lock bit in the Kupel source, possibly. I don't really know, but let's go to the bench and pop this bad boy out. And theoretically, this should act more or less as a serial in, parallel out shift register. Let me see really quick. I actually need to go steal from another project I have. A nice handy Banco 8 LEDs, which should work pretty good. And I believe the way I built this, the way I wrote that source, this is actually going to be the output side. Pin 1 is here. So these should be my inputs, and these should be my outputs. And so this should be clock, and then latch, and then all my inputs, and blah-de-blah. So firstly, let me double check. Yep, its standard VCC is on pin 20. So I will just hook that on up. Yes, VCC 20. And ground is pin 10 over here. There we are. And then I am just going to, let's see. I'm probably, let's see. I should probably just put a Pi Pico on here. Why not? It follows the theme. I am just going to take this one that I already have, and this way I can pull power off of this and also get a nice clean clock signal off of one of the pins instead of having to faff around with building a debounce circuit and junk. So that will be good. And from that, let us, let's see, this pin is V-bus, V-sys, and ground, so I think let's just pull off a V-bus. That should be 5 volts. And ground, of course. Cool. And now I have the fun job of, let's see, first I have to ground all of these LEDs, bear with. And then I will plug them into all of the outlets. I don't know if you guys can hear the rain. Like, it's pretty nice. But I worry about the security of our power here. John, or Jan, says, "Interesting, man. You did it." And I think I did. I don't know what I did, but I sure did it. Okie dokie dokie dokie. And I'm sure this is all covered up in a way that you can't see me shoving the wires in, but you wouldn't really be able to see anything anyway, so. Okay, so the grounds for all of those LEDs are now wired in. And I will just take the inputs from each of these the power lead from each LED and jam it into an output pin on the chip, of which there should really be only 7. So I just won't plug in the last one. Nice thing about these is that the way they come, these are just whatchamacallit, not solid core, braided core wire, but they're tinned at the end, and you can pretty much just shove them straight into the breadboard, which is, I don't know if that was intentional, but the fact that I didn't have to do anything special, I do appreciate. Really, these are the gift that keeps on giving. I use these LEDs from Radio Shack for everything. All right. Oh, you know what I can do? Let's just jam this one into power so that we can be sure when it's on. That's a way to do it. Okay, then, let's see. I will take my clock pin, which was pin 1, and I am just going to connect that to the GPIO 0 on the Raspberry Pi. This should be, I think 3.3 volts is a valid logic high for these chips, even though this is really a 5 volt part. I think that should be fine. Pretty sure. Then on the other side, I'm just going to take 6 wires and pull them off of here. 1, 2, 3, 4, 5, 6. And jam them into the inputs on this chip. And then I will attach the other side to 5 volt and ground, depending on what output I want to get for testing. So I'll probably just put an alternating pattern on them to start. Damn it. I yanked out 6 and I really want 7, don't I? Because I have 6 rows on my keyboard, but actually, factually, I need that old sense pin too. And let's just stick that one in power. Okay, so for these guys, I am going to, let's see. Yeah, none of this is going to be especially visible, so you're just going to have to trust my description. So I'm just going to do power. Pull them apart a little bit so I can deal with them a little bit easier. Power. Ground. Power. Ground. Power. Ground. And that should be that. Now I just have to, I don't know if I have MicroPython on this particular Raspberry Pi, because it's not the one we were using yesterday. We will see. Let us plug it in and pull up Thani and see what happens. Which, again, I should really have a screen. I guess I could set up a scene right now that has there, you can kind of see what's going on. Yeah, why not? Let's, even just in the screen, let me just add an existing thingy so you can see my monitor. Why can't I work OBS right now? I guess display capture? There we go. Add existing. And that is going to be huge. Oh, I'm looking at the mouse on my screen. Nice. Let us shrinkify that a touch. And you still probably really won't be able to see much over there, but it's there now. And it said board in FS mode, so my guess is this is in raw bootloader mode, and I will need to install MicroPython, which thankfully is real fast. this PC. Well, it doesn't show up as a removable drive. Interesting. If I pull it up in Funny, do I get a Python prompt? Well, let us see. Hey, nice. Okay, it already has Python on it. Lovely. Which means I should be able to do from machine import pin. Nice. Okay. And let's make a pin called clock, and that's going to be GPIO 0, and it is going to be a output, and we will set clock to clock dot low. Cool. And oh, dang it. One of these. Oh my goodness, how did I even program this? I did this 2 seconds ago and I've already forgotten how the thing was programmed. So pin 9 was call sense, which is... yeah, it's all the way down here. So actually, I am going to want to... oh, right. So this pin, which I thought was my call sense wire, is actually, when you're in registered mode on these things, is output enable, which is grounded anyway, so that's fine. And which one did I make my latch pin? Because that's important. That is pin 2. So actually, well, manually controlling that is absolutely fine. That's totally fine. But that means I still need to add another wire, because now I only have 5 wires for my to represent my keyboard row inputs. And well, you know what? Let me just shift them down, because they're already, one nice package. So actually, this is my column sense bit, which is going to detect when we are on column 0. Then we'll just move all of these down 1. Which is trickier than we would think. There we go. Okay, cool. And then I just add another pin for my latch mode input. See whether it should latch from its inputs or shift out. And let's set that to, well, let's bring it high, because the first thing I want to do is latch in these inputs. And if I go over to Thani and I set the clock pin, which should be wired over here to GPIO 0, and should be going to my clock input on this chip. If I do high and low, it doesn't do jack. So that's good. Cool. Interesting. Let me just make sure I have power everywhere I should have power. Is power making it over to this side of the board? It is. Huh. Fun. Wait, no, was I looking at the wrong one being output enable? I think I was. Yeah, no. This is ground, which is attached to ground, as it should be. Output enable is the one across from it. Add another wire. This is output enable. And if you ground it, you should... there we go. There it is. So that is right, because I had my... you can't really see them all that well, but these are alternating. Just because I haven't checked in a while, Jan said, yeah, one can hear the rain, which it stopped now, ironically. And Cliff Cheney says, I miss rain. Currently based in Cairo, rarely get rain here. Yeah. Man, I would love to just visit that area of the world. I mean, Egypt in particular, obviously. Ancient aliens. I want to go see ancient aliens. No, I mean just like going to the... oh my god, what is the big museum? What city is that? That's not in Alexandria, is it? But yeah, like the major archaeological museum there. Would love to, obviously, see the pyramids, see some history, but I don't know. Egypt just stands out to me. Okay, so if we clock it again, there we go. So that part is working. The latch mode is working. I grounded the first one and then latched again. So when I change this, I'm changing this back and forth, and it don't do jack because these are registered inputs. And now I've put that back to the 5-volt rail, and if I clock high again, there we go, flows right to the output. So that part works. Now let us see if the shifting mode works, which is if I set latch to low and do this again. Hey, look at that. Works perfectly. So that's something. Nice. And then if I pull latch high again, let's just do this. There we go. And if I switch latch to ground, I can do this all day. Yay. Shifts them out. Perfect. What fun things could we do with this right now? Because I could plug this into an NES and do stuff with it and sanity check it. Dare I do that? Because the other thing I can do is just get a keyboard real quick, and I guess I can pull these wires out, and I can do a small demo of just like activating a single row of the keyboard. So let me go look at my key map again, which is somewhere hiding. Sure. All right. Here it is. So let's just run power only to the first row. Or 1, 2, 3, 4, 5 seem like easy ones to play with. And that is on, I already know this is pin 7. And I know this is pin 1 over here. So, 1, 2, oh, I can just do this. 1, 2, 3, 4, 5, 6, 7. So if I just, let's see, how shall I do this? Yeah, if I just connect this to 5 volts, so that connects the whole row there to 5 volts, but none of the keys are pressed, so none of the outputs are actually connected to anything. And then we can hook up our rows, and that's gonna be we are going, oh boy, I have to recount these. And of course, I have source in the other Raspberry Pi Pico that says what goes where, but yeah, I don't have that right now. Anyway, 15, 14, 13, 12, 11, 10, 9, 8, I think. 15, 14, 13, 12, 11, 10, 9. Pin 8. So that should be just the next guy. This is my row 0 pin, and I will put it in the row 0 input of our chip. And let's see which one is row 1. That is pin 15, 14, 13. 15, 14, 13. And this will not be such an impressive demo as I'm building this, because we're not matrixing at all. I just have one line hooked up, so it's going to just be column 7 that we are going to see the output of. But it should give you an idea how this side of things is going to work. Okay, then row 2 is the next one. Very convenient, that. And I believe row 3 is 15. Very nice. So that's the first 4. And then 5 and 6 are, let's see, that is 15, 14, 13, 12, 11, 10, 9, which I believe, so this was 7, this was 8, making this one 9. And then the very last row is 15, 14, 13, 12. 15, 14, 13, yeah. 12 is the one right next to the last used one here. Cool, cool, cool. So, as usual, you're not going to see jack here, even if I go over to Thani and clock it, it's still all zeros. But, let's see, if I press down the 1 key and then clock it, it still does nothing, because I have clearly messed this up. Really? Did I grab the wrong row? Let's see. I mean, I guess I'll just try all of them. 2. Just making sure I actually have it plugged into 5 volts. Yeah. Oh, I don't have it on latch mode, do I? I do not. Let's see. No. That's the issue. To latch things in, you need to be in latch mode. Okay, that's something. Why would they all be high? That don't seem right. They should be all not high. I mean, I guess it's not like I'm pulling them high or low. That's a bit of an issue. Let's just try something really quick, because if they just naturally float high, then instead of having my pin 7 feed power, I could have it feed ground, and that might improve things. So if I don't press anything, they should still all be high. And then let's try 1 again. Yeah, there we go, and that grounds the pin. So it looks like maybe this gal has natural pull-ups in there. But if I press 1 and I latch everything in, then that one goes low. If I release it and latch it in, yeah. So I mean, this isn't really surprising. These are just acting as 8 switches, feeding, you know, their status into a shift register. But that's basically, well, a third of things. I was going to say half of things, but it's a third of things, because that's the part that's going to read each row, and now we can shift this all in. If we switch from latch mode to shift mode, then after we have clocked 1 row in, then we can, or latched 1 row in, we can shift them out to the NES, and the NES can read those, and then we would move on to the next doodly-doo. You know, thingamajig. You know, matrix line. Jan yet again says, great job. Thank you for just being such a plucky guy, Jan. And Cliff says, what keyboard is that? Yeah, so I assume you haven't been tuning in then, which, more power to you. The more people who randomly roll in here, the more interesting my life gets. This is an old keyboard from a TI-99 4A computer that I ripped apart years and years and years and years and years ago when I was but a young lad, and threw away the rest of the computer because I'm a moron. But I still have it sitting around, and it's nice because it's just like this ribbon is just the matrix pins for the keyboard matrix directly, so that makes it easy to interface with and build any kind of interface for it around. Yes, so that's that. What time is it? 6:26? I'm aiming to wrap this up around 7. So how about we move on to the next chip? So I'm trying to think. Because I need... I need a chip for scanning through the matrix lines. And that should happen basically at 1/7 the rate that I'm clocking in keyboard row lines. Basically what I was just doing just now. And I'm wondering, because one way I could do that is just make a counter and use that to divide down my clock and feed that into my other chip that will slowly step through the matrix lines. But the other option is to just use the latch input, because every time I want to read another row of keys, I need to raise and lower the latch line, right? I need to lower it, do a clock, then raise it. And every time that happens, I should be moving over by a matrix line. But is that going to be... I mean, I guess I can just play with it and see what happens. That's probably the best way to go, is just to just do it, see if it doesn't work. But, you know, latching and changing the matrix line at the same time... is it like gonna just catch the edge of things and be unreliable? Or will it manage to... I mean, it looks like this does its latch on the rising edge of the clock, right? We're in shift mode. So when it latches stuff, let's see. So it's low right now, so if I do high, yeah, it latches on the rising edge of the clock. So, if it latches as soon as the clock goes high, and I use the clock for both the chips, presumably the output of the other chip changing will lag this chip sampling its inputs. I think that's probably pretty reliable. I think that probably makes sense. So I think I'm just going to try doing that. The other chip, I guess, let me also just put a latch input on it, and, you know, several outputs, and then I will wire it very similar to this chip, but it will do absolutely nothing on every clock if the latch is not set. And if the latch is set, then when the clock happens, it will rotate things down by one position. One issue is you always have to have... because I only want one pin turned on at a time. And how do I... if you're using a counter and then a decoder, that always works out very well, because it's always gonna... you know, the counter is going to be at some number, and a decoder always decodes whatever your input value is. Like if you have a 4 to 8 decoder that lets you input a 4-bit number, and then it decodes it to 16 discrete wires, right? And only one of them can be on at a time, depending on what the input number is, between 1 and 16. But I can't really do that internally with one of these, which is a bummer. I could potentially... well, I was going to say I could potentially have a reset input on there, that when you clock it, when reset is high, then it resets its state, which, you know, its reset state would be the 0th pin being off in this case, because I'm gonna ground each pin in turn. But that doesn't work for various reasons. What are the reasons? The reasons are that, right, the whole original thing that I just don't have an extra output on the NES controller. I only have latch and clock, and then my one data input, and that's it. That's all I have to play with. So what do I do? What do I do here? I mean, my several options are... I mean, I guess let's fall back to the easiest one, and what I will do is program one chip as just a straight up counter and another chip as a decoder. Though let me check really quick, because I might have decoders. It is possible. I'm looking at my parts bin right now. I don't have a ton going on. What is a 74? No, a 7486 is Zors. I just looked that up. 74574s are 8-bit wide flip-flops. 74245s are bus transceivers, not useful. 7408s are like... Is that an 8-input... Is that an 8-input AND or something? 7408 pin. That is a... Oh no, it's just ANDs. Interesting. You know, I thought I had... Let me look at my miscellaneous ICs thing. Because, boy, is there a lot of weird stuff in here. Let's see... Oh, 74138. I think that's what I was thinking of. I think a 74138 is a decoder. Maybe? Yeah, it's for like address decoding, but I think it might be usable. It's like for decoding memory space if you're building a computer. Yeah, give me a data sheet. So I can just make a sort of special counter with one of my other gals, and then hopefully just use one of these 138s to decode that into 8. And I think these are, since this is for doing chip, for asserting chip selects on peripheral ICs, I'd have to imagine that they are, yeah, they are active low, which is exactly what I want here. I want them to sync to ground if you press a key. I think that's perfect. Yeah, I have 7 outputs, which is exact, or 8 outputs, which is exactly what I need. And yeah, I can just set these enables to just always be enabled. And then my select on CBA. Yes, I can use this. I can totally use this. So let's do that then. For starters, I guess, since I know I have one of those and I can use it, I'll just set that aside for the moment. And let's go back to, since I already have this screen up, let us save this and also save as... I had PSIO for parallel shift... parallel... Oh, that should actually be PISO. Parallel in, shift out. Whatever. Don't worry about it. So I'm going to call this latch count dot PLD, and I'm just stealing this because it should be quite similar. But what we're going to do is, yeah, I'll just have input 2 still be latch. There's going to be no such thing as the column sense pin anymore, and there are actually going to be no inputs except for clock and latch, because we're just going to count. And the nice thing is, we'll just use like the low 3 bits of this count or whatever, and it can start up in some quiescent state, whatever it is, and that's the whole point of the column sense line, is that I'm going to use that. That will be connected to one and only one of the matrix lines, the first one. And so for that one, when that matrix line is selected, it will pull that column sense line low and cause the 7th bit of the keyboard column that you're clocking in to be low only if you're on that row. For all the other ones, I'm going to pull it up to 5 volts and it will be high. So that's how you tell you're on row 0. Yeah, can't remember. I think I was going somewhere else with that before I started going down that path. But regardless, we only need to count between 0 and 7. So we only need 3 outputs. And what we're going to do is we are going to gate everything that we do with latch. Firstly, we can get rid of most of these. So for the counter, Q0 is going to... Let's see. I have to think about this, because it's... You can't just do plus plus. I mean, you probably can. There probably is a way to do that in Kubel, but if you're describing it in terms of raw logic, you can't just do plus plus. So it's going to be whatever... Let's see. When you're doing like a ripple counter asynchronously, it's really easy to implement counters as a ripple counter if you've never seen a ripple counter before. Let's see if there's just an article on ripple counters. Ripple counters real easy. Yeah, if you just look at digital counter. It'd be nice if I could get this into readable mode, but whatever. Ripple counters are easy if they have the thing here. Yeah, this is not the kind of ripple counter I was going to. You can do it with a D flip-flop. That's what I'm looking for, is if they had a example with a D flip-flop. But the basic idea is, you know, a D flip-flop takes whatever is on the D input pin, and when the clock clocks, it sets the flip-flop to that value, whether it was high or low. But so the real trick is you feed the inverted output of the flip-flop to itself as input, and then you also feed that as output to the clock of the next flip-flop in the row. So basically, you know, every time the initial incoming clock clocks, it flips the value of the first flip-flop, because its next value is always going to be its current inverted value, so it just flips back and forth. But then every time... it's also a clock divider. A counter and a clock divider are the same circuit. But so when that second flip-flop flips back and forth, which takes 2 clock cycles, that clocks the other one. So when you get a clock, it flips this one, then flips it back and flips the next one, then flips this one again, then flips it again, which, you know, flips this one again, and also, if you had another one plugged onto that one, would flip that one. So ripple carry, real easy, but it requires you to have control over the clock inputs of all of them independently, which we don't have here. All of them run off the same clock input. So I think from what I've seen, you just gotta write it out explicitly. So for now, let us gate this the way the other one did. So we'll only count if latch is high. So if we're in the latching mode, then we will count and move to the next matrix line. Otherwise, if latch, again, let's do the paranoid double parentheses. If not latch, then we want it... Hello. One disconnect during a storm, and the funny part is the storm is actually over, so that's not too bad. I will take it. Anyway, so yeah, if the latch is pulled, if the latch pin is pulled low, then they should just retain their current value on each clock. That's an easy one. So again, if not latch, then it just retains the current value of Q1, and if not latch, then it just retains the current value of Q2. Now this one I need to figure out. So I guess this one is easy, right? Because this should toggle, this should just, the lowest order one should just toggle every single time the clock happens. Yeah, right? I think so. So if Q0, so it should just be and the opposite of Q0. So if latch is high, then when the clock happens, Q0 just flips to the opposite of whatever Q0 was. So that's our low bit. It'll just keep toggling on and off. That one is nice and easy. Okay, now what do I do for the higher ones? So let's think about the second bit. If the clock, we'll just think about in latch mode. We're assuming the latch is high because that's where we're in this expression. If the latch is, did I already say hi to Ocelot? I should have said hi to Ocelot. I think I said hi to Ocelot. Ocelot deserves having hi said to them. Also, Wotek, I think, said hello, and I never said hello. And I should say hello. Hello, Wotek. Let me know if I totally butchered that. Anyway, right, so thinking through this logically, if the clock happens and Q0 is currently 0, then we would have no reason to flop Q1, but if it is 1, yeah, is it that easy? So just, if it's, let's think about this. So if we get a clock and Q0 is 0, then when that clock hits, Q0 will flip to 1, and if in here we just put Q0, then it'll be what the previous value of Q0 was, which is 0, which is fine, because if Q0 is 0, then we don't need to count this one. We don't need to flop Q1. But if Q0 is 1, then what's going to happen is it will flip back to 0 when that clock happens, and Q1 should flip to 1, which was the previous value of Q0. So I think that works. I think that's all this. I think we just cascade them like this. Yeah? Does that work? Is that how that works? I don't know. We're going to find out real soon. And let me just use that same logic on Q2. Wait, no, you can't use that logic on Q2 because there are multiple clock periods during which Q1 is going to be high. Yeah. So do we only flop... Oh, we only flopped Q2 if both Q0 and Q1 are 1 when the clock hits, right? Yes. Yes. Yeah, it's that easy, right? So it should just be and if Q1 is on, or let's go in order of precedence. Somehow I typed a euro. Interesting. This is not a European keyboard. So if Q0 and Q1, and apologies if you are, a electrical engineer or something and are like, come on, dude, this is like the easiest thing. Everybody learns this. I didn't go to school for that, okay? Get off my back. But yeah, so if Q0 and Q1 were both on when we were latched and the clock came, then Q2 should also become 1. In all other cases, it should not become 1. Wait, does that not still work? Fudge. Because then, when it goes back to... When either of those change, it's going to go back to 0. Dag. Do we have to do this the other way around? So if Q2 is already 0, nobody has any guidance for me. If I could do this as a logic table. I could do this as a Carnot map. I'm not going to. If Q0 and Q1... No, let me come at it from the other direction. If Q2, the current thing that we are dealing with, if it is low, then it should transition to high only if it is already low and the other two are high. When should it transition to low? It should transition to low. Well, we want to toggle it, right? Whenever Q0 and Q1 are high, and a clock comes, we want to toggle Q2. So if we think about it in terms of that, then it should become the opposite of whatever it is when all of these things are true, which you normally do by ANDing stuff. Like, I think this is like the worst way to write it, but I think that's how that works. So if Q0 and Q1, let's assume this is at 0. Q0 and Q1 have both counted up to 1, 1. We get another clock. If that is the case, then Q2 is 0. Opposite of 0 is 1. So it will take on the value 1. Now let's just look at the next clock. So now, after that clock, Q2 is 1. Q0 and Q1 will have both gone from 1 back to 0. Right? Right? I might have to go back and revisit Q1 again and rethink that through. But assuming that they have both gone back to 0 is the way that it should go when you're counting. Then, when this next clock comes through, Q0 and Q1 are both 0. Q2 is 1. And since these are not true, then this is all going to be... It's going to reset it back to 0. Damn. Damn, damn, damn. That is not... You cannot simply just AND it to... crap. Oh, wait. Right, if you're doing like an AND guard thing like that, you do all of this and this value. So that's like our flip condition. So if all of those are true, then it is all of those and this. But then the trick is you have to have your other state, which is if these are not true. So let's bag this all up into another set of parens. There is a way more clean way to write this. Like, there is much more sensible logic, but this is the Joe way. Okay. So we just have two of these nested patterns of like using a guard and the negative version of the guard to have two different values depending on the input. Kind of like it's you're multiplexing between two values. So we have the outer one that's just based on latch, but for this inner one it's going to be based on latch and what the value of Q0 and Q1 are. So this one is going to be if not latch and Q0 and Q1. If all that is not true, then we retain the current value of Q2 and don't flip it. I'm gonna roll with it and just test that. Don't worry about it. That logic makes sense to me. It's like a multiplexer inside a multiplexer. Okay. Now I wanted to revisit this Q1 business because I kind of didn't trust it for a second. It's going to be really easy to step through the states of these. So let's say they're both 0. When the clock comes, Q1... Wait, sorry. This is already wrong, because I wanted it to take on whatever the current value of Q0 was. Whoops. Okay, so if a clock comes in, and I want Q... and they're both 0, then Q0 is going to be 0. And this just stays at 0. Which is fine, right? I can already see where this is going to go off the rails in a minute. I see what's up. But then our next one, now during that clock, Q0 became 1. So when our next clock comes in, Q0 is 1, Q1 is still 0, and the clock comes in, it takes whatever the value of Q0 was, which is 1. So it becomes 1, and at the same time, Q0 will transition back to 0. So now, Q1 is 1, Q0 is 0. Next clock, Q0 is 0, Yep. So Q0 is 0. This is where our problem is. And this'll, that'll clock back to 1, that's fine. But this will also cause Q1 to take on the current value of Q0, which was 0, which will make Q1 go back to 0. So now we're at 0, 1 again, which is incorrect. It should be 1, 1. So I think we just kind of steal this pattern again. So bloody bloody blah. I don't know, slap some parentheses on here, why not? So, but we won't be based on Q0, and Q1 will just be based on Q0. If Q0 is 1 and we get a clock, then we need to flop the value of Q1. Otherwise, we retain the current value of Q1. Same thing as the one below. So, not Q1. Or the opposite condition. If not, latch and Q0 then just use the current value of Q1, and almost assuredly all my parentheses are unbalanced. Let's see. Use my classic counting technique. Open, open, close, close. Open, open, close, close. That was fine. Open, 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 close, open, close, close. Open, 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 close. Yeah, that's right. I knew that felt wrong. Okay. Open, 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 close, open, close, close, open, 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 close, 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 close. Cool. Pretty much trust this last one too, but let's just double check. Open, open, open. Close, close, open, close, close. Open, 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 close, close, close. No, something screwy there, because I still haven't... Oh, I'm still inside of a thingy, an expression. Oh, we need an extra one here to wrap this whole thing. Glad I checked. Yes, cool. Let's build it. Let's build it. And this one should also be relatively easy to test, because basically it should start up in some random county state, and then it should just proceed to count in a binary fashion as long as, or rather only when, the latch input is high and we clock. Right? Yes? Does that seem reasonable to you? I don't know. There's only one way to tell. One warning, 0 errors. Bam! Let's get another one of these, who's a what's-its. What are they called? They are called gals. Let's get one of these gals over here. Let us bend those legs into shape, because it's a fresh, shiny new chip. Honestly, I feel like surprising amount of progress today, considering. V happy with where we are. I think tomorrow I might even be able to, if this more or less works, we might be able to start writing software on the NES for reading keyboard, and I don't know, I didn't think I would get there so soon this week. Okay, let's give that some ground, and let's give it some power. Let's make ground brown. That seems good to me. Grounded. Let's give it some power. Power being red, that seems right. That seems right. And that is on this side, yes? Yes. She's powered. enable, output enable, which is fun because we can't see anything. And then we will just share that old clock pin because that's what we're going to do when we're finished anyway. So I will just take the clock pin from the other chip and run it to the clock input of this chip. Done. And then it will be the same thing for latch. It will share the same latch input. Lovely. And then let me just find 3 LEDs. Did I use up all of my... Oh. I've got a couple of them attached to this current NES cable. That's a controller cable. And that might be all of them. Huh. So I think we're using discrete LEDs, y'all. Which is fine. So let me take this nice big bag of LEDs that I have sitting around, which are actually nice bright LEDs. They're very good. I think they will show up just fine on camera. And get myself some resistors for those guys. Let us see. Where the... I have just like a resistor to run nothing. Right here, hiding. Cool. What are these? 510 ohms? Sure, that seems fine. Get myself 3 of those bad boys. Megaton just says mod and a wrench. Yes, I guess. I guess this whole thing is... I have no idea what you mean by that, but it is like one kind of big, horrible mod. I'm modding the NES, I'm modding the Super Mario cartridge itself, I am modding this poor, beleaguered keyboard. Megaton says, learning from you, Super. Oh, that's very nice, but I would not call me Super. I'm just a guy with weird interests. Alright, heaven knows if you will even be able to see these on the stream, but I'm gonna put them here anyway. I'm just going to move some of the grounds for the other LEDs over so I have some room. And long leg goes to positive. Short leg is going into ground. Because that's how you do an LED. And there are some LEDs. Wow, look at that. Ah, you can see them. That's fine. And then just connect the output of this chip to the LEDs via resistor. Cool. And like I said, it's going to start up with some garbage value. Because that's how flip-flops are. They don't, like, just reset to 0 when you apply power to them. They just take on whatever value they feel like. They steal it from the ether. Oh my god. The legs on this resistor are so frickin' thin that just trying to get them in the holes is bending them. Oh my lord. Good lord. I'm not sure I can use these. Let me just be really bougie and instead of trying to like work them around a corner, I'm just going to put them right in line with the resistors and then run a wire over it to it like a clown. Which is also funny because I'm going to have to redo this entire thing on an actual breadboard forthwith. And by breadboard, I mean, you know, solder it together into a proper soldered thing. You know what I'm saying. Okay, extra wires to the inputs. They go. Everybody loves the arbitrary me counting on this channel, so a 2. A 30. That's it. And they all started up all on. Is that reasonable? Who knows? Okay, so currently, let's see, I'm losing track of my wires, but this guy is still my latch wire, and latch is currently set to high. So if I go back to Thani and use it to clock my clock line, will it count on these LEDs? Oh, hell no. Hell no it won't. Of course not. Did I even program this chip? I didn't even program this chip, y'all. Wow. You just let me do that? You just quietly let me go ahead and do that? Jesus, you guys. Alright, rip the chip out with malice, with no care for the fact that it's in an active circuit. Rip that sucker out. Oh, come on. Come on. Oh, I really got wedged in there. What are you doing to yourself, sir? There we go. I'm sure that will be just as fun to get back in. And that's just in a gangle of random wires. Super cool. Alright, let us pop this in here like it was supposed to go the first time. And let us go back to the programmer. Stephen Wright said, "We should have known when you had to bend the pins." You're damn right, Stephen. The fact that I just bent the pins and then jammed it in there and I was like, alright, let's go. Questionable. Wouldn't there have to be a step that goes between taking it out of the new parts bin and putting it in the PCB? Cool, my JED file didn't end up here for this one. That's interesting. Why? Why? Should have built there. Let's open latch count again. Run. Device dependent compile. Cool. That's fine. Hello? What on earth? So I feel like these aren't supposed to be in the same folder. Maybe that's part of my problem. Let's see if I had it in the source folder. I mean, it's got stuff. It's got things. Oh, you foolish man. The name of the output file is not the name of the source. That would be too easy. It's this, you dingus. Grr. That's real dumb. But at least I caught it pretty fast. Like I'm on it today. I'm feeling pretty sharp, which is not saying a whole lot, but it's saying something. There we go. Latchcount.jed. And hopefully that's a reasonable program. Go for it. Oh, And at the same time, I should read. Cliff said, sorry, I got distracted by the bending pins. Thought I had just missed it. Just saying the same thing. Stephen Wright says, pro tip, use a pocket protector sized flathead to lever the chip out of the breadboard. Yeah, I have some of those around. I've used so many things. If you've looked in some of my old videos, and I don't remember where it's gotten to, but I also used to use just this giant oversized safety pin that came from somewhere. I'm pretty sure it's my wife's, and I'm not supposed to be using it for that, and I don't know that she knows that I've been using it for years, and that's real shitty on my part. But that works for regular dip things, but also works for getting PLCCs out of their sockets too. It's very nice. But I'll have to remember that. Lately, I've been using my my SparkFun tweezers for everything, which have gotten horribly mangled. But moving on. Okay, let's jam this back in and see if I can actually make it do things now. Make sure you line the pins up right. Don't burn it out. Well, the funny thing is, legitimately, I don't think, for all the stupid things that I've done, I have ever actually burned out an IC. I mean, I think because modern ICs are so well built at this point and have so much good ESD and, reverse voltage protection shit, I think it would be pretty hard to. But, okay, this seems somewhat more reasonable. You can't really see because the lighting is really weird in here. Like, it's too bright. I need a different bulb. But yeah, middle one is on. That seems like a more reasonable random startup value to me. So back to Thani, and let's give it some clocks and see if it counts. Hey! 1, 2, 3, 4, 5, 6, 7, 0, baby. All right, so that's a perfect place to cut it off for today because it's 7:08, and I am getting. I think I said this last time, and so that would sound weird. It's not just that we do this every night. I was gonna say getting Chinese food with my wife and hanging out for a minute, but and you'll say, didn't you do that last time? And it was the plan, but then we got something else because it was too late. So tonight we are getting Chinese food and hanging out. So yeah, I got both my chips working the way they need to. Obviously, I haven't demonstrated using the let's go to face cam. I haven't demonstrated using the 74 138s yet, but these should just, they will take that count and they will transform it into, it was 3 in, 8 out, right? Which is exactly what I need. It's exactly what I need. And it uses negative values, which is also exactly what I need. So this will just take this counted binary value and turn it into individual pins. And we'll get that slapped in next time and probably start soldering things up. I don't know if I should write code first or solder a fixed breadboard in place, but regardless, that's some pretty good progress, honestly, man. It's only Monday, and the keyboard hardware is designed and programmed. And I did it with 2 chips, which I'm very happy. Well, this will be 3 chips. I did it with only 2 GATs, which I think is pretty good. But we'll have to see if that using the latch to move the matrix line is reliable or not. Anyway, Stephen Wright says, enjoy your food, and I am going to. Thank you guys very much, as always, for tuning in. It was a good time. I feel like an hour and a half is a perfect stream length. And firstly, Megaton says code first. You're probably right, because if I need to redesign because the code finds out that there's issues, it would be nice to not have to desolder everything. So you're right. Next time, we will code. See you, Cliff. See you, Megaton. See you, Steven. See you, everybody else who's watching, because I know there's a bunch of quiet people too. So see you around, and as always,